everybody, to another expert talk. As you are aware, research on ALS is continuously progressing. At Everything ALS, we are dedicated to uncovering new discoveries, aiding in early detection, very important, and working towards finding a cure for ALS. You can assist us, and we would really appreciate it, by participating in our speech study. The purpose of the speech study is to enhance the diagnosis and prognosis of ALS. We are seeking participants to provide 5 speech recordings, each lasting 15 minutes, once a month over 5 months. Pretty easy, and it'll make a huge difference. We welcome healthy participants, as well as individuals diagnosed or probable with ALS to join us. To enroll, please visit everythingals.org/speech project and fill out our form. Thank you so much. You will find the email address posted in our chat. And with that, Christian, welcome. Christian is our executive director, and he will be taking it over.
Hi, everybody, and welcome to tonight's program. Happy to be here with the community once again for our expert talk series. A little bit of housekeeping, as always. This program is recorded during the presentation period, and for the initial Q&A, for the Q&A time provided to our expert who's joining us tonight. And questions, you can ask them anytime throughout. We will just address them at the end of the official presentation. And of course, afterwards, we'll turn off the recording. We don't post the recording of community discussion, which will follow. Now, I'd love to introduce tonight's speaker. Tonight, we're welcoming Paul Wicks, PhD and Vice President of Neuroscience at Sano, a company which combines genetic testing, patient recruitment, and long-term engagement to accelerate precision medicine. Tonight's program is titled Light the Way, Dismantling ALS One Gene at a Time. And Paul is the architect of Light the Way, which offers those at risk of neurodegenerative conditions such as ALS no-cost access to online genetic education, counseling, and testing. The platform helps connect gene-positive individuals with clinical research opportunities and provides de-identified data and support services to the life sciences industry. In addition to providing much-needed resources for a typically overlooked population like our ALS community, a major focus for Light the Way will be building equitable, sustainable, and transparent funding partnerships with key stakeholders to drive the program beyond proof of concept and to maximize its impact to reach as many patients and their families. Previously, Paul was an independent consultant, and before that, he led innovation at Patients Like Me. And Paul has over 200 peer-reviewed publications, including work in patient registries, decentralized clinical trials, patient-reported outcomes, and applications of medical artificial intelligence. He has sat on the editorial boards of the BMJ, the BMC Medicine, the JMIR, Digital Biomarkers, and The Patient. And his PhD is from the Institute of Psychiatry at King's College London, where he explored cognition and neuroimaging in a genetic subtype of ALS with a postdoctorate in psychological consequences of Parkinson's disease. His work has been profiled by the BBC, NPR, CNN, the Wall Street Journal, and the New York Times. And in 2011, he was awarded MIT Tech Review's TR35 Humanitarian of the Year Award, recognized as a TED Fellow in 2012, and joined the inaugural Flyer program at the Academy of Medical Sciences in 2019. It's an honor to have Paul. He has been an incredible contributor and friend to so many communities through his work. And so we are really welcoming him here tonight. So Paul, at this point, I'll turn it over to you. Welcome.
Thanks so much, Christian, and thank you to Everything ALS and the organisers. It's great to see this engaged community really going from strength to strength. As you might be able to tell, I'm speaking to you today from England. So I'm over in a little place called Ulroas. It's a tiny little village near Lichfield in the Midlands of the UK. So the nearest big city is Birmingham, about 110 miles north of London. And if you can do your time zone maths, it is a little late. So I've had a few cups of tea to perk me up, but I'm sure your questions and engagement in today's conversation will certainly do that too. So I'm just going to share my slides. I hope that these cooperate nicely for me. Brilliant, thank you. So the program that I'm going to talk about today is something that, for those of you particularly based in the US, you can go and visit yourself at lightthewaystudy.org. all one word.com. Check it out, see if it's of interest to you, maybe of interest to family members, other people that you've spoken to about your journey so far. So before we begin, I think it's very important to always be transparent about one's conflicts of interest. So I work for Sano Genetics. It is a private company. And towards the end of the talk, I'll share a little bit about our business model. So I have stock and stock options in the company. And when I was an independent consultant, I worked for a number of companies in digital health across trials and mental health and things like that. But the ones relevant to ALS, I've just highlighted here. So I've done some consulting around clinical trial design and other aspects to do with ALS for Biogen, Ionis, LifeArc, which is a charity in the UK, Patients Like Me, and then Unite Genomics over in San Francisco. I think it's also important to talk about one's personal conflicts of interest. So I am a researcher. I have been a researcher since 2002. And as I'll relay in a moment, I'm also related to a family member who's currently living with ALS. Throughout the talk, if I end up saying motor neuron disease, then apologies in advance, but MND is what we call ALS in the UK, just to be confusing, but I'll try and keep consistent. So the first thing I want to say is I am a neuropsychologist. So the thing I specialize in is cognition in ALS and depression and psychological aspects of the condition. I've also done a lot of work in digital health at communities like Patients Like Me. But I'm not a geneticist. And if you want to go really deep on these topics, the wonderful news is that the expert talk series that Everything ALS has hosted on YouTube really contains the absolute dream team of experts, and these are all very recent talks. So I would suggest if you wanted to double click on something like C9orf72 or something like that, you've got a great resource here. And so I apologize in advance if I don't know the answer to a deep genetic question, but I work with a team at Sano, and we have a great advisory board that helps us to close whatever gaps I may have. So, as I've said, I got into ALS a long time ago, and it actually was not because of a personal connection. I did a psychology degree. I got very interested in the brain, got very interested in autism and other neurodevelopmental disorders, and applied for dozens of PhD programs all across the UK. And then I got an interview for something called motor neuron disease at the Institute of Psychiatry that I didn't really know an awful lot about. But very quickly, I was intrigued because I was basically dropped into the middle of an argument. And the argument was, does ALS cause any cognitive issues? Or when we do see any cognitive or behavioral issues, is that just a perfectly reasonable emotional reaction to the illness? Or is it something that we're missing because as people lose their speech or they're less active at work, there's some other change going on that's not biological? And it was particularly important for us to try and understand if there were subtypes of ALS where these cognitive changes, which I think now are relatively widely accepted, were different. And so my job was to go and find everybody with SOD1 ALS in the entire United Kingdom. And so I thought, showing up to a leading institution that I could, I'm getting a bit of echo there. There we go, thank you. So I thought quite reasonably, that if I'm coming into a hospital and this disease has been studied for many years and there's all these experts, I could just plug into the big magic database. Well, find me all the patients with a SOD1 mutation in the UK. Surely that's all recorded somewhere. As it turned out, that's not the case. And it took years of developing contracts with other hospitals, making negotiations to go up there, and then physically going through their paper notes one at a time to find people with the relevant mutations. And as you can imagine, it was frustratingly slow. So I only managed to find 7 people with SOD1 ALS in the entire UK in 3 years. And one of the really tragic things that occurred was during all that time doing the paperwork, some of the patients at some of those sites died before we could even get a chance to invite them to research. So that unfairness, that frustration that we weren't able to really untangle this really, struck to the core, I think, and lit a fire in my belly, as did the fact that when I was going out to see patients from Newcastle in the north down to sort of Exeter in the south, that because I was seeing them at home, those that were in their 40s and 50s, their kids were often there. So my test battery that I would give to people would have puzzles, games, brain teasers, that type of thing, all to try and work out what different parts of the brain might have any changes in ALS. And whilst they were doing that, I would often play with their kids. And I did have this very profound sense that if we don't all get our acts together and cure this disease, then in a few decades' time, these kids are going to be in the same clinic that their parents were in. And so, I think, again, you do find a lot of very passionate people in this field. And I think this is in part why, because we realize it is often a family condition. So my work was focusing on neuroimaging and neuropsychology. I was incredibly blessed to be working with some real leaders in the field. So Sharon Abrahams developed something called ECAS, which is very widely used in a lot of clinical trials. Amar Al-Chalabi was a collaborator, a mentor of mine. And then Dr. Martin Turner, who now leads a lot of the research at Oxford, did this neuroimaging work with us, where we found that, as predicted, that when people had difficulty naming objects, that was actually associated with changes in their brain. So it wasn't just that people weren't, working, or they were depressed or something like that. There were actually changes in the brain that were not just in the motor, the movement regions, but also in other regions like the frontal lobes. And we now know through genetics and other imaging research that there is more of an overlap between ALS and frontotemporal dementia than was previously identified. But none of that was the reason I got into the field. And in an absolutely incredible coincidence, when I'd been in the field for about 12 years, my father-in-law was diagnosed with a slowly progressive form of the illness. So it started in his left leg, and here he is using a walker, probably about 7 or 8 years ago, when my eldest daughter was very small. Currently he uses a power wheelchair, and my eldest has got a lot bigger. She just went back to school today. So he's now had it for about 10 years, and is certainly severely affected, and currently is not able to speak using BiPAP for a little bit during the day. And so suddenly I found myself on the other side of the desk. It was actually my research collaborator, Martin Turner, who ended up making the diagnosis. It was actually his care team that I had done all this research with and gone to all the international symposia with that ended up looking after him. And it was just such a crazy coincidence that I think it made me feel, well, given that I've been on both sides of the fence, how could I use my experiences to drive change in the field? So that's really been a major focus. So as part of that, he underwent genetic testing for research, and many of you may have gone through this experience as well. And I really can't explain this feeling of the sword of Damocles hanging over you as you and your family are waiting to hear the results of those genetic tests. Because obviously, if it turned out that my father-in-law carried a gene for ALS, as many people do, that would have implications for his children and his grandchildren. And again, I took myself back to those, those kitchens, those living rooms of people with genetic forms of the condition, just thinking, we absolutely must solve this problem. So my work before that involved an online community that you may have heard of called Patients Like Me. That was founded by a couple of brothers whose third brother, Stephen Hayward, had ALS. And one of the things we did was gave people access to their ALS functional rating scale, a questionnaire or an interview or a clinical interview that I've spent an awful lot of time working with. I think that the data and the community and the platform that we built at Patients Like Me did a lot of interesting things. We actually did a lot of work with ALS Untangled, did a lot of work with clinical trials. But a couple of things I want to point out. So one is this very unfortunate shape. When it's one person and the functional rating scale is going from a 48 down these percentile curves, that is, of course, an incredibly difficult circumstance. The community at its peak, contained data from over 10,000 individuals. And these shapes pretty much all go down like this, barring a small handful of reversals that we know about. And one of the things that I think is a really important contribution is that this data is now publicly available. So it's been archived with the ProACE repository that's run out of MGH. So this contribution that everybody has made can really count for something, and be used in research. But when I had spent so long watching these graphs go down and to the right, this was the big bombshell. If you haven't already seen this graph, it's from the story of a girl called Anna, who's shared her, her image and her name publicly. And this is Dr. Neil Schneider talking about the impact of an antisense oligonucleotide against one of the genes implicated in ALS or FUS. And the first time we saw this graph, which I think was at NCALS in Barcelona last summer, there was a sharp intake of air and a lot of crying. Decent amount of it for me, I'll be honest, because I have seen this graph 12,000 times, 12,000 people. I have never seen this graph, and I want to see an awful lot more of them. And it's worth delving into the story and learning a little bit more. The story of JC Fuson, which is Interna treatment, named after another young woman with a condition with a specific mutation here. But I think it gives hope, a story of hope. But what it really speaks to is about targeting the condition. And I feel like when we go back to the textbooks and we go through a lot of the research studies, what we call ALS is probably many, many conditions. And it's very difficult for us to stratify those. It's very difficult for us to pull apart the phenotypes. But one thing that is incredibly useful is the genetic drivers of those. So the gene that this young lady had, FUS, is the third most common gene. It's still pretty rare. And what we're going to talk about now is what would need to happen? What would the global infrastructure need to be in order to make more stories like this, create more ticks that go up and to the right across the community? So, you know, until we had this one example, though, it still remained theoretical. So a brief recap then. So many of you will be aware of some of this. And like I say, there are other recent talks that have covered this in more detail. When we talk about genetic ALS, historically, it was thought to be quite uncommon. So when I first started training, and sometimes when I speak to neurologists that don't specialize in ALS, the understanding is that only about 2% of ALS is genetic. We now understand that it's more like 20%. So a very significant expansion in the proportion of ALS that can be explained by genetics. And when we say that, you know, roughly 1 in 5 will be genetic, that is, you know, across a range of different sites of onset. So it doesn't necessarily drive if it starts in the arms or the legs or the bulbar region. And there are some correlations between the genotype people have and the phenotype people have, but still very hard to tangle those out, to disentangle really what the driver is just from how the person presents. So there's a few things that maybe are an update if you haven't been tracking along closely, but are quite important principles. So this is on the left is a recent graph from a group of leaders across the field, across the nations, and there's 2 stacked bar charts here. And on the left is familial ALS, so ALS that goes in families, and on the right is sporadic ALS. And sporadic is just where there doesn't seem to be a family history, but as we'll come to in a second, that's still a slightly tricky distinction. So within people where there is a known family history of ALS, the majority of them have this gene that was, again, only discovered about 12 or 13 years ago, the repeat expansion of Sano Nor72. Now, in a family, that can code for ALS. It can code for frontotemporal dementia. So this is a form of dementia where people's behavior
I'm so hungry,
changes.
so I'm going to eat the rest of the salad. Would you like a little more?
So that you might be aware of FTD more recently, because that's a condition Bruce Willis has. It's a condition Wendy Williams has been diagnosed with. And it's obviously more down the cognitive, memory, and behavioral aspects of neurology. Some individual can have both ALS and FTD in that same individual, and you can imagine how challenging that would be. SOD1 is the oldest gene that we know about. We've known about that since the early 1990s. And in the US, there's recently been the approval and access to an antisense oligonucleotide called tofersen or Qalsody, which is made by Biogen, for which there is a trial for people who may carry the gene called Atlas. And you know, it's being reviewed by other countries, both from a regulatory perspective and from a payer perspective. But then there's this longer tail. And so FUS, for example, FUS, that's the gene that Anna had, that remarkable young woman. These genes are very rare, and they're scattered all around the globe. So if you think it took me, you know, 3 years to find 7 people with the second most common mutation, and I was looking quite hard, how are we ever going to get a critical mass of these people is an important question. The other thing that's worth bearing in mind is that research in the past 5 to 8 years has showed that actually what we call sporadic ALS, or what we used to call sporadic ALS, often is associated with genetic changes too, with variants thought to be pathogenic and leading to the expression of the disease. Now, there could be a lot of reasons for this. It could be that people's family histories are incomplete. You know, if your grandparents died during World War II, we've lost that information. Most people didn't live to a ripe old age going back a couple of centuries, so they may not have had the chance to express ALS. It also may have been they didn't have the access to get a diagnosis. There's also something called a de novo mutation, where you may not inherit a mutation from your parents, but it might sort of come out fully formed, if you like, when you are born. And so there are a variety of important factors to bear in mind. But you know, the first assertion I'd make, or the first update to a lot of our general thinking about this, is that perhaps rather than thinking about, you know, sporadic versus familial, you know, familial implies that it's all about, did you have a family history? Well, plenty of people don't know their family history. Plenty of people are adopted. Plenty of people have incomplete information. And so therefore it might be more useful to talk about things in terms of singleton, as in if there's one person in the family diagnosed with ALS, just to say that so far that's all we know, but that other people could get it in the future, right? So it's sort of a temporary label, if you like, versus the fact that if we were to systematically genetically test everybody, we would actually find there are many more people walking around with so-called sporadic ALS that have a SOD1 mutation, that have a C9 mutation, because of course for every one of these familial people there are 4 of these sporadic people. And then of course if you start thinking about their children, their descendants, there's actually a lot more people out there that could potentially be really interesting for research, that could be in these pre-symptomatic studies, than perhaps we have the ability to look for. I would say, you know, there is a terminology that's evolving now around gene carriers. So when I was training, these people were sometimes referred to as pre-symptomatic. And I think that terminology is a little bit problematic, actually, for 2 reasons. One is there's something called incomplete penetrance. And what that means is that not everybody who carries a gene like SOD1 is going to get ALS. It's very difficult to predict the exact numbers, but it's important to say it's not 100%. When you say someone is pre-symptomatic, it sounds like they're almost guaranteed to get ALS one day, and that's not the case. So, you know, I think at the moment we talk about gene carriers. You may hear asymptomatic gene carriers, you may hear pre-symptomatic gene carriers. But the point is that historically, a lot of the communities that exist have been for diagnosed patients, rightly so. They have the most unmet need right now, and caregivers. But potential gene carriers often haven't had services, often haven't been able to take part in research, sometimes face barriers like insurance discrimination, stigma, that got in the way of really, you know, being more active participant in the broader community. Like I've alluded to, you know, I think there's a greater overlap than I think we've acknowledged historically between ALS and FTD. In about 2 weeks' time, I'm actually going to an FTD conference where Dr. Michael Benatar, who I think has probably spoken here before, and who designed the Atlas study, is actually speaking. And at the last international symposium just gone in Basel, they actually had joint sessions between ALS experts and FTD experts. And because the mechanisms and the genes are very similar, it seems likely that we're going to increasingly want to collaborate on our research efforts. And the reason I mention that is because it's important to say that right now the way funding is allocated, the way some of the hospitals work, the way the diagnosis sometimes works, and what care is available, siloing ALS and FTD into different buckets is probably unhelpful from a research perspective. I think something that's really important to acknowledge is that most of the research that takes part happens to be in, you know, urban specialist tertiary referral centres. So tons of data coming out of London, Oxford, Boston, San Francisco, you know, Miami, the Netherlands. What you end up with is a very white, very educated population from richer countries. And oftentimes, because taking part in research is quite difficult, it's quite burdensome, those people tend to have more resources as well. So what we've ended up with is quite large genetic populations that risk some serious diversity and inclusion issues. So I think that's something we need to address. And then finally, one of the things that I sometimes find a little frustrating is that now that we know there's this whole mosaic of genetic causes for people, both in terms of a gene associated with a cause of ALS, but also genes that may increase the risk, or some variants in the general population that, if you do get ALS, can make you end up with a more aggressive form of ALS. It frustrates me that sometimes when we design a clinical trial where we say, well, anyone can enroll, that actually those with a genetic subtype may be better served being, sort of stratified off into genetically targeted therapies, because it may be if we accidentally recruit too many people with, say, an aggressive form or a combination of aggressive forms of different genes and put them into an all-comers study, that we're going to lose signal. If too many people with more aggressive forms accidentally end up in the placebo group or the treatment arm, it can blur those effects. And so whilst many trials do collect blood samples, a lot of them don't actually analyze the data unless something doesn't work out later on. And I actually think it'd be much more useful to stratify people earlier on and say, well, actually, you'd be more eligible for a gene therapy, you'd be more eligible for gene vaccines, or other things that are coming down the line, given how rare these people are and how precious their contribution would be. So where are we today? So, in terms of care, who is offered testing is very variable. At some centres, it's every patient diagnosed with a condition. At many other centres, it's only if you have a very clear family history, one or two family members, particularly if they've had a genetic test before. And the way that it's done is very different. So some places will only test for SOD1 and C9. If those are negative, then they'll go on to test other genes. Some places take a broader approach and go for a whole panel, but there's no real consistency. So what that means is if I magicked up 1,000 people from across planet Earth who all told me they'd had a genetic test for ALS, that probably means 800 different things. And that's a real challenge for consistency. Genetic counselling is something that everybody should have before they consider getting genetic testing in order to understand if it's right for them. And access to genetic counsellors is really restricted right now due to a shortage of counsellors. And then when people do get the results, there's not always a lot of dedicated care and support available to say, oh, well, perhaps if you are someone who's got a genetic cause, how do you deal with issues like guilt or stigma that might come across? And then if you need to have a conversation with your children, what support is there in place to do that? So I think that's an area that we need to shore up. The good news is that there are international consortia of experts who have started to get the conversation going and build consensus guidelines for how we should be doing things. So Dr. Harms, who spoke here recently, is one of the people putting that together. But it'll be a long way before that's implemented to the case that, say, when I get my 1,000 people from across the world, they've all had similar consulting, similar counselling, similar testing, and similar support. And that's something we really need to drive. So on the basis of what I said then, so this is really kind of getting at why the Light the Way initiative was put together. So the notion is that the people who are at risk of genetic ALS, whether they have the disease now or they're a family member who could be at risk, they tend to feel quite alone, quite isolated. They have a number of fears that many of them report. They face barriers to care. They worry about burdens, and they have very consistent and specific needs, particularly around education, because, as you can imagine with all we've just said, this stuff's very complicated and changing quite rapidly. And so people need to have good information, otherwise misinformation can spread, or, as one person who was there at the hospital appointment who could only understand half of it, when then they tell their brother and their nephew and their niece, that whole game of telephone means that the information kind of degrades as it goes through, right? So we need high quality, consistent education. So the program that we've developed was funded initially from the UK government through something called Innovate UK. And the concept is that at no cost to our users, we're developing a multinational online platform so that we could provide these individuals at risk with high quality genetic education, so developed with support of genetic counsellors and people with lived experience, neurologists, researchers, that we could offer pre-test genetic counselling, so over a video call like this one, where once people have all the information and the education, they could decide whether or not testing is right for them. Testing is not the right decision for a lot of people. If they're interested to go ahead, we have a saliva-based home spit kit that we can send out. People can also upload their prior genetic results. So if they've already been tested, and there are a number of programs and research studies and things like that that might have offered them testing in the past, they can upload those results. And if they need to, they can actually book in a post-test genetic counselling session to have that explained to them if they have any questions. We're going to try and plug everybody into peer support, and there's a non-profit organisation called End the Legacy that I'll mention in a moment, who we work very closely with. And we want to signpost people towards high quality education about some of the topics that are very difficult to discuss when you only have a few minutes with the ALS expert. So this might include things like family planning. So maybe not so much for ALS patients, but if their children potentially carry the gene, they may be interested in family planning options to ensure that they have the right information at hand for any decisions that may need to be made there. And then we want to make sure people can be plugged into research studies. So because of the rarity of these mutations, people may need to travel, they need to fly to go and take part in studies, but we really want to make sure people have those opportunities. And then as gene therapies come online, which I think we all are looking forward to, we want to make sure there's not a gap. So what would be terrible is if a gene therapy was available for someone with a particular mutation, and because of these gaps in diagnosis, gaps in counseling, gaps in return of results, a period of time elapsed before they could actually get that therapy. We all know time is neuron, time is function. And so we want to see if we can get in there as early as possible and really make a more consistent approach with people. So like I say, if you want to check it out, it's at likethewaystudy.com. And that's in English as well as US Spanish, which again, we're hoping to see if we can address some of those inequity gaps. So overall, the concept is if people were to come to something like a virtual waiting room, so if they're getting emails every month, if they were able to access this type of education, that we might be able to inform them about different types of trials going on. So natural history studies, observational studies, so things like you're talking about with speech analysis would be a perfect example, but also these interventional trials and understanding the impact of things once they go on the market. So our goals for the program, primarily it's about improving access to research, to trials, and really helping families to engage. Ambitiously, we want to take this out to many more countries. So although we've launched in the US, we want to see if, because it's a digital platform, we can take it to other countries. When you travel abroad, Uber often works, in European cities and things like that. And it's quite nice that it's all one app. Could we do that? Could we help address some of these equity gaps? Could we help make care more consistent and the application of research more consistent? I think, as I alluded to earlier, I started my career in tackling myths about cognition, for example. I wonder if we can do the same for tackling some of the stigma, the myths that hold back the field. And then finally, what I would love to be able to help support is a large-scale preventative trial. So if people have the gene, might there be different interventions, whether that's pharmacological or even lifestyle modifications that could have an impact on the onset of disease? And I think Dr. Jonathan Cooper-Knock will have spoken with you about some early evidence on that just recently. So how does this work in terms of working with partners in the life sciences industry like biotechs and pharma? Well, the idea is that if you actually look at all the different challenges that industry faces, they actually need an awful lot of information to help develop new treatments. So when something's in early preclinical development, many of them would benefit from getting saliva samples, doing more genetic analysis with samples. If they were to launch a product, they would maybe benefit from understanding what countries people are in, maybe what parts of a country people are in. And then overall, I think this issue of raising education about genetic issues would help to close some of these gaps that we've identified. So far, we've been trying to keep a track of how the education is going with people, and we actually have some data I'm preparing for this conference in a couple of weeks' time. So far, we've delivered education to about 100 people in the US and genetic testing to 20 of those. And so far, we've seen an incredibly high rate of satisfaction with the education provided. And I think that's so important because it's such a confusing, such a frustrating area. And we're seeing a very high proportion of people really feeling like the education supported them to make that right decision for them. And like I say, a big part of what we do is on the digital platform. We're very keen to hand people off to members of the community. So End the Legacy has a variety of programs. I join their calls most weeks when I can, but they've been very involved in research and education. One of them's actually going to be presenting a poster. Gene Swidler, who's the executive director there, will be presenting a poster at ISFTD. There's also a lot of community support. So conversations like this one, town halls like this one, where people can really share what's been going on with them. So in terms of next steps, like I say, this is a global problem. And this map is sort of colored in with density of where all the people on Earth live. And these arrows are where most of the research comes from. And you can see already there's a bit of a mismatch there, isn't there? That, you know, there's vast swathes of Asia in particular, of Africa, of South America, Latin America, Central America, Eastern Europe, where there are major gaps in research, in data that we're gathering, and in information support that we're providing. So our ambition for sort of the next development of Light the Way is to say, well, if you look at the full stack of all these very complex modules that we've developed here, so the education, uploading prior genetic results, counseling, testing, all this kind of stuff, might we be able to do lighter weight implementation, sort of a Pathfinder, if you will, to go out to multiple countries where we could move faster because we will start just with the education, so translated and localized to their region. If people already have their genetic reports, they can upload those, go straight to the virtual waiting room, and then that will allow us to sort of assess, you know, what is the demand like, how can we raise awareness, where can we partner with people, and then if there's enough demand, if there's enough need, if we can find local partners that want to do this, then we could look at upgrading that countries like the Way program to something more like Lighthouse. But bearing in mind that there are many countries where counseling is available, there are many countries where testing is available, and there are many countries where the regulations are very different to the US, which tends to be less restrictive on these things. So that's my job, is to make this thing on the right-hand side a reality, and to try and make it a reality for as many places as possible. Just quickly then, so on the business model, so, you know, we are a for-profit company, we are not a non-profit. We work across many therapeutic areas, so not just ALS. We've done work in COVID, in Parkinson's, in inherited deafness, an awful lot of things. We'll be transitioning this from the original grant that was funded to working with some of the biotech sponsors that we know. And we think it's really important to say, you know, it's the users themselves that own this data. So, you know, we are licensing the data, we're only using de-identified, anonymized data for our research. And one thing that's often asked a lot from users in the US is whether or not this genetic information would appear in their medical record. So in our case, no. You get a report, you get told about that report by your genetic counsellor, and then it's your decision. We obviously would hope if you have an ALS specialist, you share that information, but that's your right to do with as you please. In terms of how this differs from other programs, we're using saliva, and you can do that test at home as opposed to having to come into a hospital or have a blood draw. It doesn't need a physician to order that test, and we have quite a broad set of genes so that, you know, we can hopefully go a bit beyond any single study. And, you know, like I said, I'm hopeful that the US Spanish translation will be helpful to a broader array of people. So I hope that's been a useful whistle-stop tour of, I guess, my background, my motivation, and what I've been up to. And yeah, I'd welcome the chance to answer any questions and explore your thoughts on this.
Great. Thank you so much. And we've opened it back up to the community for some Q&A. So we do have a couple questions to start. So I'll read them out, and my colleague Sylvia is going to join here we'll take turns with them. But first and foremost, Paul, does the ALS FTD correlation depend on the type of genetic mutation? For example, is it more likely for those with SOD1 mutations? Has that been found?
So it's actually the opposite. So we think that people with SOD1 may be less likely than people with other types of ALS to have cognitive involvement. So the clearest overlap we see is in people with C9orf72. And then there are other genetic variants like GRIN, also known as progranulin, or MAPT, can also have an overlap there. Just on cognition, it's important to say, you know, most people will not notice any massive changes or things like that. A relatively small proportion of people may have behavioral changes. They may be more disinhibited. They may have trouble with planning and things like that. It's not always something that can be noticed. Often it only shows up in specific circumstances. But the reason we talk about it, and it's awkward to talk about, it's uncomfortable to talk about it, is because sometimes when it does happen and people have really profound changes, their caregivers notice, but the patient themselves can have a loss of insight. They might not know that they've had a change. And so it's important to raise awareness of this so that caregivers know they can go and you know, speak to the care team and flag this up, because the old saying that the body is affected but the mind stays completely the same can be unhelpful if it does actually go on and people have that that behavioral change. People may also have mild problems with cognition, but it tends to be of quite complex planning. So, if you're trying to plan like a big Thanksgiving meal and when do I buy what and when do all the timings go on, which can be hard enough as it is, those are the types of tasks that tend to be more challenging in sort of milder cognitive impairment. But yeah, there's a lot of great resources online. I'd encourage you to take a look at resources on YouTube and from the major ALS nonprofits on this, or if people have got specific questions, I'm happy to follow up. And yeah, if you can get hold of my old supervisor, Professor Sharon Abrahams, she'd be a fantastic person to have to do an expert talk.
Thank you.
Alrighty, the next question is, if not all people with the same genetic risk factors will develop neurodegeneration, then how strong of a factor are genetics?
This is, I was going to say it's $1 million question, but that doesn't seem big enough. It's a $1 billion question. So a couple of concepts there. So this overall concept of penetrance, where just because you have a gene does not give you a 100% chance that you'll get the condition. So there could be a few things at play. So one is we've got to be very careful about looking at historical research that mostly looked at people with ALS and then checked out what genes they had. What we don't have is a big pool of, say, all the healthy Americans that also had that gene that never got ALS. And just to complicate things further, you have to take into account that people will die of other things. They will die of heart attacks and strokes and bus crashes and things like that, right? And so we don't know if they'd lived forever, would they have eventually gone on to get that condition. So that's the type of thing that we are increasingly looking at. But there do seem to be people who are, like I say, walking around with a C9orf72 expansion who will never get ALS. And there's a few things we want to look at. One is, do they have some other genes that might be protective? So, for example, you can't tell, but I'm quite tall. There's not a tall gene. What there is you have a bunch of taller genes and a bunch of shorter genes, and they all sort of sit on a weighing scale, if you like. And if you have a bit more taller genes and not so many shorter genes, then you tend to be a bit taller. But it's not 100% guaranteed, right? It's kind of like weighing scales and the roll of a dice rather than exactly determining it. So some of these people may have a gene that's protective. Dr. Rick Bedlack, who's been doing some work on these ALS reversals, has actually recently found a genetic variant that seems to be elevated in people who have had a confirmed reversal. So there may be something like that. The other possibility is there may be risk factors that are environmental. There is no smoking gun in ALS. There have been a few clusters here and there and everywhere. Guam, people have looked at lakes and occupations and the military and all these types of things. But even then, those only tended to sort of double very rare odds ratios. It's not like cancer, where you see people from a particular occupation. So back in World War II, for example, the ladies that licked the paintbrushes that made the tritium watches glow all got orofacial cancer. So that's a very clear link, or look at smoking or asbestos in lung cancer. We don't see links of that magnitude. So it's probably more subtle. My colleague Amar Al-Chalabi has written about what he calls the 6-step hypothesis. So it may be that the average person needs to have 6 things go wrong before they develop ALS. But it could be that if you carry a SLOD1 mutation, a C9 mutation, that maybe you don't need 6 things, maybe you only need 3 things. It's too early to recommend any lifestyle interventions as a result of this early information, other than general lifestyle stuff. I personally would not be keen on people doing activities that end up with a lot of head damage. That's a general rule anyway, but I imagine if you were a gene carrier and you were boxing during the week only to play football and rugby on the weekend, and then banging your head against a brick wall at work, these things are probably not helpful. But it would be nearly impossible to do a proper study to determine exactly how much is too much. Yeah, it's early days with that.
Thank you. The next question was a question posed really on a personal level of having somebody who has performed the exome and C9orf expansion and did not find any genes associated with ALS. What would be the best recommendation? Are there constantly new tests coming or other ways to validate?
Yeah, so if it's a whole exome panel that's been done with relatively recently, I think all that means is that for the genes that we know about now, those are negative. That's reassuring. That means that from what we know now, you probably are not at an elevated risk either of expressing the condition if you're asymptomatic, or of passing it on if you are a symptomatic individual. That said, one thing I want to flag for people, if they had a test 10 years ago, then there may be some genes that weren't covered. So, for example, we have seen when we ask people to upload their historical reports, it may not have had C9orf72 at the time. So if you go back 5 or 6 years, that test was expensive, it was fiddly, not every lab was doing it. And yet, as you saw earlier, that is the most common gene that people with a genetic form have. So yes, if you're looking at results from a long time ago, or if there's a mom or a dad who passed away 20 years ago and had some testing, just to as a reminder, just to say that there's probably been a lot of updates since then. The best scenario, if you are an unaffected individual, is to ensure that any family member with ALS has a comprehensive genetic test, because otherwise it's almost impossible to interpret what's going on further down the line. But yes, if someone's tested negative for all the known genes, then yeah, I would say then you're in that sporadic category, that singleton category, and should approach any research studies for which you might be eligible if possible.
As a follow-up before we get into the next question, was there an inflection point in the last 10 years or a certain milestone reached when it came to testing, exome testing or otherwise, where a certain test, once it came out or was hit a certain milestone of improved granularity or precision that you can speak to, or is it kind of an ongoing thing that people just need to stay aware of and consistently checking back in?
No, that's a great question. So the cost of genetic sequencing has come down very dramatically. Going back 25-ish years ago, the Human Genome Project spent billions of dollars to sequence one person. Now you're talking about a few $100s to sequence somebody. However, not all genetic testing uses the same procedure. And up until recently, like I said, this C9orf72 repeat expansion needed to be done in quite a separate, quite a specific fiddly way that could be error prone. So that's probably the biggest change that's become easier to do, the C9. The other thing that's happened is the researchers, the clinicians have got together and they've agreed which tests to include, which genes to include in a test panel. So there's now more consistency than there was. There is still uncertainty. In fact, there's a whole group of genetic variants called a variant of uncertain significance, and that means that we may not have enough evidence right now to determine whether this variation in SOD1 is something that could lead to disease or more information is needed. So, that's why even if you don't have a clear history, it's still, I think, useful to contribute. One of the other efforts that's been put together is the use of global user IDs, so that if someone was to be sort of a super research participant and they were going to fly to Miami and Boston and San Francisco and take part in everybody's studies, that we have ways now of making sure we don't count that person 3 times, right? Because if they're very rare, and we said, well, gosh, we've got this 55-year-old male with a super rare variant, now we've got 3 of them. Well, no, we now have these global user IDs that allow us to say, well, this person's got the same age, name, date of birth, and we can track that without transmitting the data around those different hospital sites, those different databases, which can be an issue of data privacy. So again, these are small incremental upgrades in the overall research infrastructure, but they've been really, really helpful. And I think the other thing that's happened is, countries have been pulling resources together. So obviously the US is the superpower. The Europeans decided they couldn't compete unless they all ganged up, basically. So the Europeans are very collaborative, and in some cases, because they have smaller countries, right? Some of the countries might only have between 2 and 8 million people. All the patients might come through one centre and have a more comprehensive testing regimen. And so countries like Ireland produce a lot of evidence. Countries like Italy, the Netherlands produce a great deal of high quality evidence in a consistent way that can be pulled together. And that's really showed us that different populations do have different risk factors. So in North America, the most common form of SOD1 that you all have is called A5V. It's a more aggressive form of the condition. People tend to be more in the 18 to 24-month prognosis than some of the slower variants we see. Whereas in Sweden, people of Scandinavian origin often have more of a recessive gene called D90A, so it's a form of SOD1, and they have a prognosis measured in decades in many cases. So again, I think this is why it could be important to understand the signature of these conditions. It won't be relevant for everybody, but it'll be relevant for enough people that if we pull them into databases, if we invite them to trials, we try and take this more personalized approach, then my hope is we pull the thing apart sort of thread by thread.
Thank you, Paul. Sylvia, do you want to take the next one?
Yes. So the next question is, can a C9 change, but not enough of a change to be considered a mutation or evolve into a real mutation over time?
Yeah, so C9 is an interesting one. So C9 is not so, many people will see this metaphor of genetic variants associated with disease as being like a spelling mistake. So your DNA, your code is like an instruction manual about how to make you. And so if there's a spelling mistake, this is how to make a leg, and it accidentally says here's how to make a peg, just one little letter completely changes the meaning of the sentence. C9 is not like that. C9 is a gene where there is a little period, a repeating period of letters that are in the gene, and in this case there are more repeats of that than there should be. That's actually very similar to Huntington's disease and how Huntington's disease is identified. So the challenge is there's a number. If you're above the threshold or below the threshold, it's considered a pathogenic circumstance. But there is an intermediate, there's an in-between number as well. I think I wouldn't want to say that that's likely to change. So if you've tested and it says you don't seem to have a large number of repeats, that's unlikely to change over time, I would imagine. If you have this uncertain, if you're in this little, anti-Goldilocks region, it may be that that's something to do with the test used. It might be in the future we get more sensitive about this. And it may be that, in the future we'll be testing people for multiple genes all at once. But yeah, I would say if somebody has, tested negative, there are no certainties in this. Again, this is all probabilistic. If you're tested negative on a gene panel, what you're saying is it probably doesn't have a genetic cause. There's some other set of circumstances that's led to this. And I see there's a follow-up question here about behavioral changes. So yeah, I mean, just to say, there can be a variety of reasons why people's cognitive abilities and their behavior change from before they got ALS. Many people are clearly anxious about the future, maybe depressed at change in circumstance. It would be silly of me not to say that's not a possibility, right? It's also important to mention that fatigue, pain, sleep disturbance, these can all play a role in how sort of sharp we're feeling. And something that's really important to acknowledge is that as people's breathing difficulties become problematic, that can be a real source of issue. So if people aren't using non-invasive ventilation, if people aren't using BiPAP, or it's not being used sufficiently or not the right settings, that could have a very noticeable effect. And then finally, there are some medications that people take for things like spasticity or sleep or other things that can also have an effect. So just when it comes to cognition and behavioral change, just remember that there could be multiple different things going on. But yeah, for some people who have the frontotemporal dementia presentation associated with C9, for some people it's movement first, for some people it's behavior first, and it really varies. It can change over time, so it can be that people maybe just had something wrong with their leg, and then over the course of a couple of years, then they do start having some of these changes. One other thing that's important, again, to pull out a little bit is emotional lability, or it's sometimes known as pseudobulbar affect. So sometimes people have changes in their emotional expression. They might laugh very, very easily at things that they don't think are funny or that aren't that funny, or cry at things that aren't that sad, or cry at things that are funny. That can also come out sometimes as yawning. It can also sometimes come out as anger. And that is a sort of the brakes coming off emotional expression. Sometimes the person doesn't actually feel that way, which can be really disturbing for them. So that's called pseudobulbar affect or emotional ability. It's important to talk to a neurologist. It's important to potentially see a neuropsychologist, because again, teasing these things out is really important. And I think the last thing we would want anyone to feel is that they weren't being listened to, that they didn't have their own autonomy because of the concept of cognitive change or behavioral change, meaning that that we don't still treat people with dignity, that we don't still give them independence in the decisions that they want to make. But this is a very complicated disease, unfortunately, and the deeper we drill, the more complicated it gets. So yeah, it's certainly something that all ALS specialists should now be very keenly aware of, and there are assessments that you can do that can sort of help with that. But yeah, that's kind of the way that we see it at the moment.
Yeah, thank you for that. There's been a recurring theme that happens, especially in familial ALS, when it comes to genetic testing, where people who do get tested sometimes either get frustrated or simply struggle with the conversation within their own family. There's always people in the family who maybe just don't want to know. How have you addressed that over the years, or confronted that with your own work, both in education and recruitment, and just learning how many different peoples live and come from different cultural backgrounds?
So that's a great point, and I think I tend to be quite a solution-orientated person. I go straight to peer support. I can't tell a veteran in Missouri how they're going to have that conversation at Thanksgiving. I'm a British guy, but maybe there's someone else who's walked a mile in their shoes that can at least share their experiences, right? And yes, it is very common for the types of people in the community who come to meetings like this to be the people that want to know, and the people that don't come to meetings like this and don't want to hear about ALS and going to change the channel if they see something about the Ice Bucket Challenge that they don't want to know, they don't want to get tested. That's their right. Absolutely, that's their right. For a long time, the narrative has been, well, there's nothing we can do about it anyway. And that has changed, both because of the gene therapy that's available, but also because of the research that could lead to the next wave of gene therapies. There's also these issues around family planning that I think are important to consider. And then for people who have found out that they're gene carriers when they're asymptomatic, what they often report is that they make different life decisions. I think what's important, and actually love the work that End the Legacy has been doing on a political front, has been trying to expand the insurance non-discrimination protections in US states. Because, like I say, if you decide, okay, I carry this gene, that means I might get ALS, maybe I'm going to live in a one-story house, maybe I'm going to stay near my family, maybe I'm not going to live in the Northeast where the winters get really bad. I mean, you might make different decisions like that. But what I don't want to have happen is that someone comes along and makes that decision for you, to say, well, you can't have this job, or you can't go here, or, you can't do this, or that you're constrained in that way, because I think, that's unfair. We are all at risk of lots of different things. And also oftentimes the motivation that people have had that test is to contribute, is to share their data, is to share their experience. And if that comes back to bite them, no one's going to do this anymore, right? And so many of the discoveries that we've had in medicine are all thanks to the bravery and the sacrifice of individuals, of their time, of their specimens, of their very, very challenging conversations that they've had to have with researchers. So we've got to make sure that that's really honoured in order to continue progressing.
Thanks. Peer-to-peer engagement and education is certainly something we are completely steeped in here with when we call it citizen-driven research. Yeah. And McFinn, I know you have your crew of Pathfinders who are always here, and that's why they're here, is to be peers within the community who answer questions and who are there to bring a diversity of perspectives of their own as well, and their own experiences, given the diversity of experiences everybody goes through with ALS, right? So great to hear.
And when it comes to families, let me just put in one last plug for genetic counselors. Genetic counselors do this for a living. They are really well versed in, both supporting whole families and giving, say, that affected individual the right language, the right terminology, educational materials they can share with others, and being open and available for confidential and separate conversations. Maybe they can refer to a colleague if there's any fear about confidentiality. But, genetic counselors, although in short supply, are very valuable, very important, and they are a specialist group. So even our neurologists, our wonderful neurologists who know everything about ALS, often don't have quite as much of that time and that expertise in having really sensitive, really challenging conversations about family dynamics that genetic counselors and some of the other folks in the community do. So, yeah.
Speaking of the importance of genetic counselors, many times it's the genetic counselors who are staying on top of, updates and new releases of tests that previously would test something and a result would come back as a variant of unknown significance that now actually has something more definitive to it. And there are implications for that for going back and getting retested. So, it is important to have a relationship with a genetic counselor who can ping people in those instances. It happens quite a bit.
Yeah, it does. It does. I think one of the things that may surprise people is if you had a variant of uncertain significance, 5 or 6 years ago, many centers, what they may have said is, hey, stay in touch. Some genetic counselors do that active outreach. Many, not from lack of attention or from wanting to, many do not. Just because there's too much of a volume and find them out is very complicated. So if you've been told you had a variant of uncertain significance, it may well be worth pinging that genetic counselor once every 2 years or something, just with a hey, heads up. Again, it's unlikely that anything's massively changed, but what the system we would wish occurred would be that if something actionable changed, we'd let you know. But like I say, the day-to-day, which genes are important, which genes, which variants of SOD1 might be available for different treatments, different trials, different therapies, that can change on a week-by-week, month-by-month basis. And so, it shouldn't be up to the community, it shouldn't be up to the participants to stay on top of that. But I would recommend just belt and braces. Don't assume that you'll get an email, that you'll get a letter if you've had a variant of uncertain significance.
Michael, question or comment?
Yeah, thanks, Paul. I've always enjoyed meeting Paul and talking about this, and this was a comprehensive presentation, really enjoyed. And we do have asymptomatic study, which is partnered with both, Prevent ALS from MGH, which actually merged with Columbia. And we are recruiting about 125 participants, where we will be doing digital monitoring on speech and also with actigraph limb movement, and also upper and lower is our ambition right now. So we would like to get people who are asymptomatic to really join, and we want to make this as part of, once a quarter is what we ask you to monitor, and we want to make this a normal, status quo for everybody who wants to monitor. So this is a pilot, and if those goes well, we want to actually enhance and get thousands and millions of people who are at risk for ALS to be monitoring, because early symptoms will actually have yield a lot more result with the therapy. So
yeah,
that's our
without these sensors, somebody who's asymptomatic would never know if they were at those earliest stages. And what we want to do is change the definition of when asymptomatic really becomes symptomatic at a time when intervention has its best shot at interventional studies or trials and everything have their best shot at efficacy. So
yeah, and we've seen that in neurology. So Parkinson's disease has been transformed by this concept of the prodromal Parkinson's, right? So we now know in retrospect, people who go on to get Parkinson's may have had all sorts of symptoms, sleep disturbances, changes in sense of smell, constipation, depression, reduced arm swing, things that are just too subtle to maybe complain to the doctor about, but very important from understanding the pathophysiology. And I think, again, Dr. Benatar has led an awful lot of work on helping to define different prodromes in ALS. And I think that's really key. But to the point we said about cognition and behavior earlier, we lack sensitive tools to really establish that. A 6-hour neuropsychology battery is not appropriate to give out to everybody. And sometimes I think people can get alarmed, they can get upset if they're filling out lots of questions about behavior, or if a loved one, say, is filling out information. I think they quite reasonably have concerns about where that information is going, how that information could be used. And I think we as professionals could do a better job of laying out where that information goes.
Yeah. One last hand raise here before we let you go, Paul. I know it's late there, and thank you so much for staying up late with us.
Sure.
Howard, do you have a question or comment?
Yeah, I was kind of interested in finding out. I have the C9ORS72 defect. I'll be the 6th member in my family that's going to be, well, I'm not symptomatic yet, but I've lost 4 family members. Mother had FTD. My brother's got full-blown ALS right now. but I'm having tremors at night where my different muscle groups will just go into a quiver. And I've not found anyone that can tell me whether that's any type of relationship with ALS, or is it any type of symptomatic thing? Anyone heard if that has any relation to ALS?
Many.
Yeah, Howard. So no, thank you for sharing. And it sounds like, you know, your family's gone through exactly this experience that we've talked about different people having it expressed differently. I'm not a medical doctor. I'm not a neurologist. I'm not your neurologist, so I can't give you a specific answer on that. But I would say, you know, if you're able to find an ALS specialist near you, or I think some of the pre-symptomatic studies that offer, say, testing like repeat EMG, neurofilament, you know, or a neurological exam, then you might be able to sort of understand what's going on. And like I say, some recent updates to what is considered early or prodromal have come out. So, you know, it might be worth talking to people if you're not already, just to sort of say, okay, is there something I can do? So even if I don't feel like I'm symptomatic enough to be diagnosed, could I at least get some monitoring? Could I get some reassurance? And one of the things that has happened recently, I don't think the paper is out yet, but a group of clinicians, researchers, and people with lived experience all got together in, I think, Philadelphia just before NCALS earlier this year to actually start agreeing what the standard of care should look like for an asymptomatic gene carrier. Because right now, I mean, there's a handful of people who, with the guidance of their physician, are taking riluzole, are having repeat EMGs, are having neurofilament done. The challenge is there is no standards to this. It's not necessarily covered by insurance. There are other people who are just told, don't come in until you're really, really sick. Well, okay, we know that that's probably too late to be doing very much. And there are, you know, like I say, research opportunities that are out there. And I know people like ALS TBI, I've got a trial navigator. I know everything ALS is plugged into, all the leading experts. So, you know, we just want to make sure that as many people as possible, you know, if they are experiencing things like that, I wouldn't want to say they're necessarily signs, because there's many other things that could cause that. We want to make sure that you're plugged in and supported as best as possible.
Well, again, thank you so much, Paul. And I think that concludes our this part of tonight's programming, and we really have enjoyed it. And you absolutely have answered so many important questions. So go get some rest, and thank you again. We're gonna, or if you want to stay on, but I know it's late, so
I will. The fight starts again tomorrow, so I'll get some
Exactly.
rest. Thank you so much, everybody. Cheers.
Thanks, everybody.
Thank you, Paul.
Thank you, Paul.
You know, I'm just going to take a moment here and tell you a little bit about the Pathfinders. So we have a small group of 9 of us, and we are caregivers and we are pals. And we are here to serve all of the little things that you might come up with in your day that you might be having a problem with. I just want to say that I want to introduce you to a few smiles. Janie Gobelli. Hi, Janie. Our Pathfinder who just broke her arm and she's getting better at it. And Sean Penno. There you go, Sean. And Joe Redman. Hi, Joe. These are the Pathfinders who are on the show today, and we would love for you to get to know us. And that's why I have our little get to find us at everythingals.org/Pathfinders. So we're looking if you would be interested in joining us. Caregivers or a pal. Both of you have experiences that other folks really need. And so if you have the time and want to share your experiences, contact me, McFinn, at everythingals.org. And I'll be glad to have a little conversation with you. Now, Susan Baker, I haven't seen you in a while. Thank you so much for being here. Yeah, it's, you know, folks, we get attached, and it's actually fun because we know what each other is going through. And a lot of people just don't realize what the bottom line is. We do. And so that's why we get together and we share our bottom lines as often as we can. I know these are the gifts that we try to provide to each of you, and that's feeling that people are really working on this project with you in mind. I mean, each of you are so important, and each of you is a citizen researcher.